insofar as you guys are interested in psychology, especially in the experimental end of psychology, measurement is everything. And so much of what psychologists publish and write about is incorrect. And the reason it's incorrect is because they do not have their measurements properly instantiated. It's a massive problem, especially in social psychology. In fact, it's probably a fatal problem, in that most of the things that social psychologists measure don't exist. And social psychology has been rife with scandals for the last 4 or 5 years. And there's good reason for it. But a big part of the problem is that the measurement, that people are not stringent and careful enough about their measurement. So we're going to walk through this very, very carefully. So I'm going to set forward a set of propositions, and you have to think about them, because each of them they're axiomatic. So you sort of have to accept them before you go on to the next step. And there's certainly room to question them. But here's the bare bones of the psychometric model of personality. So we'll call it roughly the Big Five model. And the reason it's called the Big Five model is because the psychometric investigations have indicated that you can specify human personality along 5 basic dimensions. You might ask, well, what exactly is personality? And, well, that's partly what we've been trying to wrestle with the entire course so far. And I would say, or what exactly is a trait? Think of a trait as an element of personality. And I think the best way to think about a trait is as a sub-personality. So you're made up of sub-personalities that are integrated into something vaguely resembling a unity, but the unity is diverse. There are describable, stable elements that characterize you, that are elements of your being. So, for example, here's some common ones. I might say, well, are you social or would you rather be alone? So here's a good question for you to decide whether you're extroverted or introverted. It's pretty straightforward, because that's the first major dimension. Basically, if you take any set of questions about any set of questions that could be applied descriptively to a human being, and you subject them to a statistical process called factor analysis, you can determine how they group together. So what I would be interested in, let's say I asked you 100 questions. Let's say I asked 100 questions of you and 100 other people. What I would find was that reliably, if some person answered question A, say on a scale of 1 to 7, 6 or 7, there would be other questions in the set of questions that they also tended to answer on the upper end of the scale. Or reliably, if they answered one question at the top of the scale, they'd answer another question at the bottom. That's a pattern of covariation. So you're looking for how the questions covary across large numbers of people. So let's say, here's a stupid example, but it's really straightforward, easy to understand. I might say, how often do you smile? 1 to 7. How often are you happy? 1 to 7. Well, what you'd find, obviously, is that people who tended to answer that they smiled a lot would also tend to answer that they were happy a lot. And so smiling and happy are not exactly the same thing, which is why we have 2 different phrases to describe them. But they're close enough so that they seem to be reflective of some underlying structure. And so that's what a factor analysis does. It allows you to take a large set of questions, to administer it to a large number of people, and then to statistically analyze it, looking how the questions relate to one another across the entire group, so that you can infer what the underlying structure is. And here's the question in some sense. If I ask you 100 questions, how many questions am I really asking you? Because you might say, well, do you smile a lot? Are you happy? Do you wake up eager to start the day? And you say, well, is that one question asked 3 ways? Or is it 3 separate questions? And the answer is, well, if the answers reliably covary, then it's reflection of an underlying single dimension. Now, obviously, those questions are slightly different. Now, but they'll relate to one another stably. And so you can infer out the central stable factors. Now, it might be the case that, so here's an example. Because you might ask, how many stable underlying dimensions are there in any set of questions? If I ask you questions that relate to your capacity to manipulate abstractions, I'll find that there's one factor. So imagine you had an infinite library of problem-solving questions. Doesn't matter what they are. Capital of Georgia. Here's a sequence. 2, 4, 6, 8, 10. What's the next number? Here's 5 patterns. And they transform predictably across the pattern array. Here's 5 alternatives that the next pattern might be. Pick that one. Here's 10 words, tell me what they mean. Anything like that. Here's a mathematical operation, compute it. Anything like that. Imagine you had a very large library of questions like that. Okay, an infinite library, and you took random sets of 100 questions from that library, and you gave those sets to 1,000 people. What you'd find was that people who, and the score, say you gave them 100 questions, and then you summed across all the items to see how well they did. What you'd find was that people who did very well on one set of items would do very well on another set of items, and very well on another set of items. And that would be the same for people who did badly. If they did badly on any one of the sets of randomly chosen items of abstraction, they do badly on the rest. That's basically IQ. That's all there is to it. So what IQ does is correct that for age. But other than that, that's all there is to it. And the thing that's interesting about those random sets of abstract problem-solving questions is there's one dimension. That's it. Intelligence has one dimension. And it's one of the most terrifying statistics that are known to social scientists. And IQ is an extraordinarily powerful predictor of long-term success, especially in complex jobs. And the reason for that, it's quite straightforward. Most complex jobs throw random sets of complex problems at you. That's their definition. So for example, if you're working as a lawyer on complex court cases, you have to be able to read very quickly, you have to be able to abstract, you have to be able to problem solve, you have to be able to formulate arguments, and you have to do that repeatedly in different ways across very large spans of time. And so the fact that your ability to solve any set of random problems is a really good predictor of your ability to solve any set of random legal problems, it's more or less self-evident that that would be the case. But the thing is, the thing that makes IQ so damn powerful, and it's one of the personality traits, roughly speaking, the thing that makes IQ so powerful is you can basically get a decent measure of it in 20 minutes. It's very terrifying. Anyways, we'll go into IQ in some depths as we progress through the course. But you get one dimension out of a factor analysis of IQ. Now, in the personality domain, using descriptive items, you don't. You get 5 dimensions.